Very good. All right, gentlemen. Thank you as always for joining me tonight. This is Strenfest Southwest 2021 workshop number 4, the subject of which is orienteering. Have either of you guys ever participated in an orienteering type event before?
Like as a sport?
Yeah,
No. I
not
went to
really.
off-trail navigation class, but
Okay, so yeah, maybe a bit of familiarity with it, but
Yeah.
yeah,
I did one of those classes too, but really never practiced it enough for it to become like a skill of mine.
gotcha. Yeah, no
I
worries.
think I know some of the basics, but have never really practiced them, sadly.
I think that's the case for most people who are going to be attending. They've done like a class on it or two, or they've read a book about it. But Abe, like you mentioned, there actually is a sport based off of orienteering, and we're going to be doing an orienteering run at Strenfest that's based off of that sport. So the basic idea is that you're going to see, you're going to receive a map similar to this. It's going to be a topo map of the area, and it's going to have a bunch of different points on it. And you are going to get a certain amount of time to visit as many of those points as you can. And then you have to get back within the time period. And whoever visits the most points within that time period is the winner. That's the competition that we'll be doing. And in order to prove that you've been to those points, there'll be like a secret code at each point you have to write down. So we'll be able to like track progress in that way. But that's the event. And the purpose of tonight's presentation is to talk you through the skills that you'll need in order to complete that event and do well in it. So the major question, of course, is how are you going to find these points with just the map, right? And there's really two ways, right? Number one is just by reading the map itself. You know, it's a topo map, and so you'll be able to figure out based on the features you see on the map roughly where the points are. Some of the points are pretty obvious based on just the map alone. But for the more difficult points on here, or for points where you can kind of see where it is on the topo map, but you need a little bit finer tuning to dial in exactly where, that's where you'll be using your compass. And so we're going to be talking about both of those things tonight. So first off, let's talk about how to read a topo map. I'm going to switch to a different one. I think you guys are probably both familiar with topo, so we'll go kind of fast through here. But the first thing you'll probably notice when looking at a topo map are the major geographic features. So there's a road running down this map. There's also a blue river running down it. You can see here where they kind of intersect. And of course, there's other things like this marker here is a campsite, and right next to it, you can see a little blue circle indicating a spring. So you see the major features are on the map, which is what you would expect. But of course, the particularly interesting part of the topo map is the elevation lines. You see these brown lines contouring their way across the map. And the idea, if you look at this number here, for example, this elevation line is measured at 6,400 feet above sea level. What that means is that anywhere along this line, as you follow it, that's 6,400 feet. And then you'll see that there are more lines, most of which aren't labeled, but then we get to a second one, 6,600. The idea is that each line is an increase in elevation, right? And this is useful for us because based on how close or far apart the lines are, we can tell how steep the terrain is. For example, right here, it's very steep. Obviously, the lines are quite close to one another, whereas back in here, it's more flat. The lines are further apart. And so by looking at those lines, we can kind of get an image in our mind of what the terrain looks like. And that's what helps us navigate. So that's the very basics of reading a topo map. Many of the points that you'll be navigating to, you can find pretty much just based on the map itself. So going back as an example, you see this point up here, right? If you follow the road up to, say, this intersection, you'll find yourself at this intersection, find people quite near that point. You'll probably be able to go up the hill to find that point if you want, but you also might notice that, hey, it's pretty steep here. Why don't I go up and around to where this little protrusion sticks out, climb up onto the ridge and follow the ridge up to get that point? Is an example of navigating your way there just using the topo map. So I think that'll get you a decent number of points here, but I've set up some of these up quite specifically so that you will need to use compass skills in order to find them. And that is what the remainder of this presentation is going to be about. Before I go on to compass, any questions about topo maps? Good to go. Cool. So let's talk about compass work. What I have here is kind of a diagram of an orienteering compass, which you guys are probably familiar with, but this is the kind of compass that I expect people to bring to Strenfest. You've probably seen these before. Obviously, it's got the needle, like all compasses have. It has a bezel that can rotate, and it's got a flat back plate that is usually transparent, all of which go into using the compass for various navigation things. This is in contrast to something maybe more like this, which, like a keychain type compass. Obviously, it's magnetized and it'll still tell you north, but it's not really good for much more than just that. Or on the other hand, something like a lensatic compass, which just like an orienteering compass is used for advanced navigation type stuff. I've been told that these are a little bit harder to use. I don't really know how to use these very well. You're certainly welcome to bring these to Strenfest if you like, but I'm expecting most people will probably bring the orienteering ones, since that's kind of the common one that most of us have. So with that in mind, let's talk quickly about the parts of this compass and the terms that we use for it. First, of course, is the needle. It's magnetized. It's always going to point towards magnetic north. There's the bezel that houses the needle. The bezel can be turned around. This entire sort of structure here, you see it's got hash marks all along the outside to give you degree measurements. It's got this red box printed onto the back of the bezel that turns with it, along with these lines. All of that turns when you turn the bezel, but of course the needle itself does not turn because the needle is always aligned towards north. This red box, or this red thing in the back, is called the orienteering, or the orienting arrow. We'll talk about how you use that in a second. Similarly, the orienting lines are also in the back. The back of this bezel and the back of the entire backplate is often transparent, because you'll often want to be able to align these orienting lines with something on your map, which again, we'll talk about in a little bit. Finally, we have our index line that points to a spot on the bezel. That's where we'll be taking our measurements off of. And we have the direction of travel indicator, which is just a red arrow that's painted onto the base plate at some point to remind us which way the compass is supposed to be pointing. So those are the parts of the compass, and I'll be using those terms as I talk about various compass skills. So the first question is, what is the compass good for? What kind of measurements do we want to take with the compass? And the best way to explain that is to talk about the most basic function of a compass, which is taking a bearing on an object in the field. And let's explain what we mean by the term bearing. A bearing is an angle. It's an angular measurement. And specifically, the angle that we're measuring in a bearing is, if you imagine a line going from you to an object in the distance. So for example, in this picture, there's a guy looking at a mountain. So if you imagine a line going from him towards that mountain, and then we imagine a second line going from that same person, but pointing towards north. We have two lines there originating from the same point. The angle between those two lines is our bearing. That's what a bearing means. And we'll talk about what that's used for in a second, but first let's talk about just how to calculate it. Pretty simple to do with a compass, just like what this guy is doing in the picture. You take your compass, you hold it flat so the needle is free to move. And in fact, often you're told to hold it so it's connected to your body, which is kind of, we do that so that you're always certain that you're facing the same way as the compass. We'll talk about why that is in a second, but you hold it so that it's connected to your body, you hold it flat, you turn so that it's pointed at the object you want to take the bearing against, which in this case is the mountain. Once you've done that, you'll see, like in my diagram on the right, how the needle is not going to be pointing probably straight forward. It's going to be pointing somewhere else. And so we take our bezel and we turn it so that the orienting arrow, that red one, lines up with the red needle. This practice is often called like putting the dog in the doghouse or putting red in the shed. Just refers to the fact that when you're taking these measurements, you will often be turning that bezel to line the red orienting arrow up with the red part of the needle. Once you have done that, you're then able to look at your index line, this black arrow, and take a reading from what's on the bezel, which I don't have numbers on it, but imagine they were there like a real compass. And we're imagining that our reading here is 130 degrees. This is our bearing for that mountain from our current location toward, or rather relative to magnetic north. And in a second, I'll talk about why magnetic north specifically. But before we do that, we now have our bearing. Let's talk about what this is now actually good for. When we're taking a bearing on an object in the field, generally we're doing it either to communicate it to someone else, or we're doing it because we want to follow that bearing. That is, we want to go along that line. Why do we want to go on the line? Generally, it's because we want to go somewhere, right? So using Strenfest as an example, if one of those points, say, is pointing to the top of a hill, well, we want to go to the top of that hill to get to that point. why don't we just walk to the top of the hill? Why do we need the bearing? The reason we use the bearing is because if somewhere along the line we lose sight of that hill, maybe we have to go through a thick forest, you can use the compass and the bearing you took to make sure you're staying on the right track, that you're not veering off in the wrong direction. And in fact, when we took the bearing in the field and we turned our bezel with the compass to get that number 130, not only did we get the number, we actually set our compass up and locked it in so that it's now ready for us to travel towards that bearing. From now on, as we walk along that bearing, we can check our compass and confirm that red needle is still in the box. The dog is still in the doghouse. And so long as it is, we know we're continuing to travel along that bearing line, traveling in the direction that we want to go. So ultimately, that's why we're taking bearings on an object in the field, and that's how we do it. Do you guys have any questions about that? Straightforward so far? Cool. So this bearing that we just took is relative to magnetic north. And here's where we're going to bring in what starts to get complicated and confusing with compass work, which is the concept of magnetic north versus true north. The fact of the matter is that true north, which is the north pole of the Earth, it's where you have latitude 0, longitude 0. It's the point on the northern part of the planet around which the planet rotates on its axis, right? That's true north. Magnetic north is the magnetic pole of the Earth, the thing that all magnetized items will want to point towards. These two items are not in the same place. Magnetic north is not directly under the Earth's north pole. Not only is it not there, it actually moves around over time. And as a result, we need to know the difference between those when we're working with maps and compasses. The difference between those is called declination, magnetic declination. You see this map here that I've got on the right of the United States. These various lines are helping us show what the declination is depending on our location in the country. It's going to change depending where we are. So for example, we have this blue line that goes through Texas. It's marked 5 degrees east. What that means is that anywhere along that blue line, the difference between a line from you to true north and a line from you to magnetic north is 5 degrees east. And similarly, here it's 10 degrees, somewhere in between, like in the heart of Texas, it might be like 7.5, right? Now, like I mentioned before, this changes over time. And we can kind of see this because this map here shows that Arizona's declination at the time it was made looks like it's maybe about 12.5 degrees east or so. But in fact, now it's 9 degrees east. That's what this 9 over here is. And this diagram can kind of help you see that. True north, if pointing straight up, magnetic north in Arizona is pointing 9 degrees in the positive direction east from true north for Arizona specifically. Does that make sense, that the difference between true north and magnetic north? Following along so far? Very good. So you have to often convert bearings between true north and magnetic north. We'll talk about why that is in a second. But for now, just know that you do need to convert the two. When you are going from magnetic north to true north, you do so when it's in the eastern direction, which it is in Arizona, right? 9 degrees east. You add 9 degrees to your bearing. And we can see why this is, because we have this these two arrows, right? Let's imagine a third arrow. So let's say we have our 130 degree bearing on that mountain from earlier, magnetic north, 130 degrees. It's the magnetic north bearing because when we took that measurement, our needle was pointing to magnetic north, right? The compass doesn't know what true north is. It knows what magnetic north is. And so any bearing taken on our compass is relative to magnetic north. If we wanted to convert that into true north, let's draw that arrow here. Let's pretend this represents 130 degrees. It's not actually pointing the right way for that, but ignore that for now. So let's draw this little arrow here. That's our bearing of 130 degrees, right? That's our arrow. You can certainly see with this diagram that if we wanted to take this relative to true north, we need to add these extra 9 degrees in there. So that's why we add 9. That's how we get from magnetic north to true north. Now, hypothetically, if this was pointing to the west instead, you have to kind of imagine it in your head, but the magnetic north bearing would sort of start over here and go all the way around to here. We need to take out those extra degrees, subtract them in order to get the true north bearing. And so if this was 9 degrees west, we would subtract 9, but it's 9 degrees east. And so we are adding 9 in order to go from magnetic north to true north. If we are going the opposite direction, true north to magnetic north, then we subtract 9 degrees. And you can, again, see why that is. You have to take these extra 9 degrees out. So for purposes of Strenfest in Arizona, 9 degrees east, if you're going from magnetic to true, you add 9, true to magnetic, you subtract 9. Now, the math here is obviously pretty simple, right? Going from 130 to 139 just by adding 9. But if you don't want to do that math, you can also convert simply by turning the bezel left or anti-clockwise 9 degrees. And that will give you on your index line your converted magnetic to true value of 139 degrees. And that'll become pertinent in a little bit. But for now, just remember that you can also do that in addition to just adding it in your head. So that's magnetic declination. That's how we convert it. But why do we need to do that in the first place? The reason we need to do that is because maps are oriented towards true north, right? When this map was drawn, pointing up on the page, the direction that these lines are going, that's true north. It's not oriented to magnetic north. And you can imagine why, because magnetic north changes over time. They don't have to draw a whole new map every single time the thing changes. So the maps are oriented to true north. If we're going to be taking a bearing on that map, plotting a bearing on the map, that's going to be a true north bearing. And if we want to then later follow that, we need to convert it to magnetic north in order to follow it on the compass, because the compass is relative to magnetic north. Or alternatively, if we're transferring a bearing from a compass onto a map, the bearing from the compass is magnetic north. We need to transfer it to the map. The map is in true north. So once again, we need to convert that. So those are some of the reasons why we need to know that conversion factor. Let's kind of see an example of that. What we're going to talk about now is called plotting a bearing on a map. Previously, we shot a bearing in the field against an object that we could see. But now let's imagine that we're at the campground here, right? We know that we're here. And let's say we want to know, or we want to go to Milligan Peak up here, but we can't see Milligan Peak from where we are. So we don't exactly know the right direction to travel. If you draw a line on this map, you'd get the line that you want to travel in, right? But we can't see it, so we don't really know how to follow that line. And of course, in reality, we probably wouldn't follow this line straight up the mountain. But again, for sake of argument, let's say that we were going to do so. And we would want to know what our bearing is towards that line without being able to see the mountain. We can do this by drawing that line. We take our compass and we lay our compass along that line like so. You'll notice that the needle is pointing off towards, in this case, it's pointing off to the right. For this kind of stuff, when you're taking measurements off of a map, you do not need to use your needle. The measurements you're taking are solely relative to the compass bezel itself, which I'll explain in a second, but don't get confused by that needle, just ignore it. You know, the needle can be pointing any way it needs to, the map can be arranged in any way it needs to. You just need to use the compass and the map by itself. So you lay the compass down along the line. Once you've done that, the compass is now pointing in one of the two lines. To get our bearing, we simply need to get the other line, which we do by rotating the bezel so that these orienting lines in the back, these black lines, line up with the lines on the map, the north-south lines. Of course, it's not drawn here, but this compass has a transparent backplate, right? So you're able to rotate the bezel. You can see the lines on the map and the lines, you can easily line them up properly. Once you've done so, once again, you've created an angle here, which you can read off of your index line, which in this case is 320 degrees. So what that means is that from this campground here, the angle between true north and the line towards Milligan Peak is 320 degrees. That's our plotted bearing. Now, of course, that bearing is in true north. So if later on we wanted to follow it on, like we wanted to follow it on our compass, we need to get it into magnetic north to get it in the compass, which we do by subtracting 9 degrees. You guys remember that, right? Which you saw how the bezel turned in order to subtract that value, turn it to the right to subtract. Now the compass is set up to travel along that bearing of 311 relative to magnetic. And if we so wanted to, we could walk along that line to get to Milligan Peak. So does plotting a bearing on a map make sense to you guys? Doing good. Okay. So those are two sorts of things we can do with the map and compass. Yeah, here we go. So yeah, you can like set it. This is just a diagram of setting up the compass to go along that 311 degree bearing. Okay. I know next is triangulation. Was there anything else? No, yeah, the next and last major skill that I'm going to talk about then is the skill of triangulation. I guess just to summarize where we've gotten to this point, we've taken a bearing off of an object in the field. That bearing is in magnetic north, and we've plotted a bearing on the map, and that bearing is in true north, and we've talked about converting between the two. The final skill, which is called triangulation, is kind of a combination of both of those skills. And the purpose of triangulation is, like going back here, right, where we're at the Upper Blue campground. Let's say we don't know where we are. Somewhere we're on this map. We are somewhere. We don't know where we are, but we can see some major landmarks. We can see, say, Milligan Peak, and we can see Manus Peak. And let's say we can also see this flat top hill, which doesn't have a name. So we don't know where we are, but we can see these three items. We can use a skill called triangulation in order to figure out where on the map we are and get our location. And the way this is done is first by taking bearings in the field of all three of those objects. So going back to this method, we point ourselves towards the peaks. We take the bearing on the compass. Once again, let's say it's 130 degrees. Recall that this is in magnetic north, so we convert it. Well, we need to convert it to 139 because we're going to put it on our map, right? It needs to go into true north in order to get on the map, so we convert it to 139. Here's our compass set up for 139. So we're going to place the compass. We're going to turn it, the entire compass, so that the lines in the back line up with the map. Once again, ignore the needle. We're working with the map right now, not the needle. So we turn the compass itself so that the lines line up with the back of the map. Then we take the compass and lay it alongside Manus Peak, the item that we took the bearing off of, and we draw a line along the edge. So we've just drawn, like we've almost like gone backwards and drawn our line based off of the measured angle of something we could see, right? Once we've done this, we now know that we are somewhere along this line, right? So that's the first step of triangulation. The second and third steps are the identical to the first, just with the other two mountains, right? We're going to do the same thing as before, take a bearing off of those mountains in the field, convert that bearing to true north, and then draw the line with our compass. So here we've done it with Milligan Peak, and now we've done it with that flat top hill. And what this leaves us with is a little triangle in the middle. That's why it's called triangulation. We are somewhere within this triangle. Now, if we did this skill 100% perfectly, all three of those lines would cross at a single point. Very rarely does that happen. Working with a compass is inevitably going to create some kind of rough errors. But generally, we have a triangle showing where we are. We're somewhere in there, and that's usually good enough for why we're trying to do this. So that is the skill of triangulation. Any questions about triangulation, guys?
When I took a class doing this, one thing that I found challenging about triangulation or related type of activities in an area that I was unfamiliar with is that being in this new place, looking at this new map, it was hard for me to identify landmarks on the topo map quickly.
Sure. I remember having the same issue, totally.
Yep, it's a good point you bring up, right? And that kind of goes back to those skills with reading the topo map that we talked about earlier. If you look at, say, Manus Peak right here, if you kind of imagine yourself standing in this canyon, like we see this really steep hill, right? Like first of all, like let's make sure we're even facing in the right direction, right? Knowing that this map is oriented to true north, you know that if you're in the canyon somewhere, that Manus Peak is going to be in the southeasterly direction of you, right? So you roughly know, where you are, or like you're in the canyon at least, and you know where north is. You get that from your compass. You can turn to the southeast and you see, oh, there's this huge mountain rising up in front of me. Okay, well that's Manus Mountain, right? Well, Manus Peak is the highest point of that mountain. So if you see the highest point there, that looks to be roughly in the middle, kind of with this protrusion sticking out, that's probably Manus Peak. So you use your topo map reading skills in order to determine that stuff. I guess that's the best advice I have for that. It's something you just get good at over time as you work with topo maps. Is that helpful somewhat?
Yeah.
Cool. All right. So just to summarize what we've gone over, We've talked about reading the topo map. We've talked about the basic details of the compass. We've talked about shooting a bearing with a compass in the field. So again, you see an object, you're getting a bearing off that object. That bearing is in magnetic north. We also talked about plotting a bearing on the map with your compass. So you don't necessarily see the object. You're just using the map to find out the bearing between the bearing from where you are towards that object. Talked about converting between true and magnetic north with a declination of 9 degrees east in Arizona. We talked about why you would do that. We talked about how to travel along a bearing, which ultimately that's usually our goal, why we're taking these bearings, because we want to go in a certain direction. And we talked about triangulation. It's probably a good point to note that these various skills that I've gone over, at least the ones related to the map, there are a few different ways of doing them. And I've presented the one that I consider to be the simplest. Both of the ways that, both triangulation and plotting a bearing on a map, when we were working with the map, we didn't orient the map to north or anything, like we didn't have to. There are variants of this where you do orient the map to north. And if these are things you guys have worked with in the past, or anyone watching this video, if you've worked with in the past, like certainly feel free to do that. But the way I presented it is the way that I think is the easiest. Similarly, we've done all this talking about converting between true and magnetic north, but in fact, you can set your compass up so that it's operating in true north. You essentially configure your compass with the 9-degree east declination, which is something that I choose not to do. I find it easier to just do the math, but it's definitely something that you can do if you want to do that. So those options are there for you. But at least in that case, I suspect that it's likely good to learn these skills without setting up the compass for declination, just to make sure you can do it without, if that makes sense. So to wrap the presentation up, again, just showing the preview of the map for the orienteering event at Strenfest. Again, a lot of these points you'll likely be able to find based off of where you are. Like, you'll have a rough idea of where you are, and then you'll see geographic features. You'll make that correspond to a point you see on the map, and you'll be able to travel there. But some of these will require the compass. Others, the compass will help a lot. And so in order to prepare yourself for this, I recommend that you guys do at least the following. Just go outside with your compass, take a bearing off of something you can see. That can be a mountain in the distance. It can be a hill. It can be a building, anything that you can see in the distance that you can take a bearing off of. Just practice taking that number. Additionally, take a bearing off of a map, right? If you have a topo map of your area, or if you just like print a topo map off the internet, you can do so for free at several places. Do so and then take some bearings off of that map. Try correlating the bearing that you took off the object you saw to the same bearing plotted on the map and see how close you got. Triangulate something as well with the map that you've printed out that you already have. Just practice these skills, right? These are often difficult when you start out, but they become quickly easier as you practice them. And so it'll be very good for you to show up to Strenfest with these skills already sort of locked in. And then you will do better in the ultimate challenge. All right, I think that's everything I wanted to go over. So are there any questions, guys?
Garrett, do you compete in this?
Sorry, repeat.
Do you compete in orienteering?
I competed a couple times after I first learned these skills, which I enjoyed. But this was right before the virus shut everything down. And so I wasn't able to keep doing it. They have since started up again, but I haven't gone back to any of them yet. They are fun events.
Yeah, it sounds fun. I'm going to see if they do these in Tucson.
I'm almost certain they do.
Yeah, I would think so.
There's an organization here in Phoenix called, I think, the Greater Phoenix Orienteering Society. And I would have to assume there's a similar one down in Tucson as well. And Abe, I bet there's one where you are as well.
Yeah, I know that I forget when I looked this up before, but there are like state and national organizations for this. Like it's at least, enough people running the sport for people to do it.
That's cool.
It's not like a spectator sport, obviously.
Where are you, Abe?
I'm outside Denver.
Oh, okay, cool. I forget this isn't just Arizona.
No, it's the whole Southwest.
Yeah, cool.
Any other questions, guys?
I don't personally have any questions.
Good stuff. Abe, you good to go?
Yeah. Do you just not use your adjustable declination because it's more strenuous?
The reason I haven't done it yet, I guess, like, I don't know. I suppose the idea is that I don't want to have to adjust it every time I go somewhere different, but that's a silly justification because where do I go outside of Arizona? Like not many places, right? I guess I've always liked, like I was saying, right? I want to make sure I know how to do the skill right before giving myself the cheat method there, as it were.
Yeah.
But I certainly don't begrudge anyone doing it. Here's maybe another reason why, right? Like there likely are some scenarios where you do need to actually get your magnetic north one. You'll just need to convert back off of your true north calibrated compass. So it maybe does wash out.
Yeah, I would like at least the way that I've thought about it so far is like if you only do it once when you get to a place, you can only screw it up once. But if you're doing it yourself, then like every time that you shoot a bearing is an opportunity to like do the math wrong.
That's a fair point. I certainly won't begrudge anyone who does it. It's probably something that I should start doing myself.
If people are watching this video and like haven't got a compass yet, some of them do this and some of them don't.
Right. I think that most good orienteering compasses have the ability to set declination nowadays. They have like these orienteering compasses have a lot of little features in them. Like we've covered a very small amount of what you can do with a compass today, just the basics, but there's a significant amount of cool stuff you can do. Any other questions?
That's it for me.
Cool. Well, thank you guys for attending. As always, I will get this video posted as soon as I can. This is our last workshop until Strenfest itself. So I am very much looking forward to seeing you gentlemen there, as well as everyone else watching the video.
Yeah, me too. Yeah, we'll have to figure out like cars and how, if anyone's going to be like carpooling and stuff, but that's not a question for tonight. We'll figure that stuff out.
No worries, man. We can do that though. All right, guys, have a good rest of your night. I will catch you all later and I'll see you at Strenfest.
Yeah, looking forward to it. Bye, you guys. Good night.
See you later.